I'm going to walk through the factoring process. The first step is to arrange the polynomial in standard form. Standard form just means you're arranging it in order by power. Here is an example, ax squared plus bx plus c. A is the coefficient on the squared term or the quadratic term. B is the coefficient on the linear term or the term of degree 1. And C would be the term without a variable. That's step number 1. And I've got notes here that say the examples presented in the video are examples where the lead coefficient, which is A, where the lead coefficient is not positive 1, but the method that we're using in the video also works when the lead coefficient is positive 1. So this method works on all types. The second step is to look for a greatest common factor and reverse distribute that out of the problem. The reason that you're doing this is that because it enables you to work with smaller numbers, and also at the end, when you present your binomial factors, you need to have anything that they have in common should be factored out or removed from your final answer. The third step cues you to look for patterns, but I'm going to bypass that step and go on to step number 4 because the process that I'm showing you works when you also have a pattern. So let's go ahead and get into a problem, and let's do the example that's presented that says factor completely. So here the first thing I would do is check to make sure that it's in standard form, and it is. It's arranged by power. You do not have a GCF, so let's go ahead and identify A, B, and C. A is the coefficient on the squared term. B would be the coefficient on the linear term, the term of degree 1 or the x, and then the constant is the term without a variable. Make sure that you bring the sign along with the number when you're identifying A, B, and C. Just a note about the big X. The big X is just simply an organization tool, a visualization tool to help you determine which factors you're looking for to fit into the puzzle. The top of the big X would take the product of A times C, and the bottom of the X takes just the linear term, the coefficient on the linear term. So looking at this particular problem, the product of A and C, 12 times negative 5 results in negative 60. So the top of the big X is going to get negative 60. And the bottom of the big X is going to get the 11. And the way that you would think about this, you're looking for numbers. When you multiply the numbers together, they give you negative 60. When you add them together, you get positive 11. When the product of A and C is negative, that means that one factor is positive and the other factor is negative. So here you're going to use positive 15 and negative 4. The next step, you're going to take the original trinomial and you're going to rewrite it with 4 terms. So I'm going to start with 12x squared, which is the first term. But instead of writing 11x, I'm going to express 11x as a result of 15x minus 4x. And then lastly, I'm going to end this with the negative 5 from the original problem. So I just want you to stop and recognize what just happened. The original trinomial has just simply been expressed with 4 terms, and the term in the middle, or the linear term, is written as 15x minus 4x. I now have an expression with 4 terms, which allows me to introduce the factor by grouping skill. So I'm now going to group up in order, and I'm going to look for a greatest common factor within each individual binomial. So looking at the first, they share 3x. If I reverse distribute out of 3x, that leaves me with 4x plus 5. Looking at the second binomial, remember with factor by grouping, the whole goal is to recreate the binomial that I just created. So here, I'm looking for a positive 4x and the positive 5. I see that I've got negative 4x minus negative 5, so if I reverse distribute out a negative 1, that's going to leave me with positive 4x plus 5. So my first factor is 4x plus 5, and then the 2 GCFs that were reverse distributed out, they come together to create their own factoring family, their own little binomial family. And the 2 binomials that I've created from my factor by grouping represent the final or factored version of this particular problem that I started with, the particular expression that I started with. If I were to multiply 4x plus 5 times 3x minus 1, it would result in the original polynomial that I started with. Let's do one more on the video. Let's do number 1 on the video. So for starters, it's in standard form. You do not have a GCF, so let's go ahead and identify A, B, and C. A is positive 2, B is positive 5, C is positive 3. So for my big X, the top of the big X would take the product of A and C. That's going to be 6. And the bottom of the big X is going to take the coefficient on the linear term, which is 5. So I'm now looking for factors of 6 that add to 5. And that's going to leave me with 3 and 2. Noticing that 6 is positive and 5 is positive. So that means that my factors are both positive. Now for the new piece. I'm going to copy 2x squared. But 5 is now going to be a result of 3x and 2x. So this is the new piece right here. 5 is now a result of 2x, 3x plus 2x. And finally, I'm going to end it with the constant. And here, I am now going to introduce my parentheses for factor by grouping. The greatest common factor within the first set of parentheses is the x. And that's going to leave me with 2x plus 3. In my second set of parentheses, I already have 2x plus 3, so I'm just simply going to reverse distribute out a 1 so that the greatest common factor of x, so that the greatest common factor that I just pulled out would have a mate to go in his binomial. So my first expression is going to be 2x plus 3, and then my second binomial factor is going to be comprised of the 2 GCFs that were reverse distributed out. This is my final product. If I multiply the binomials in the red box, it's going to give me the original problem that I just started with. And let's look at the second problem on the video before I end it. The second problem on the video, let's see, it's arranged in standard form. I do not have a greatest common factor, so I'm going to go ahead and write the big X. A is 5, C is 6. So the top of the big X gets 30. Notice that the linear term is negative. The linear term is negative, but the product of AC is positive. When the linear term is negative and the product of AC is positive, that's your cue that you're looking for 2 negative numbers. And this is going to lead you to negative 15 and negative 2. Notice that when I multiply those numbers, I get positive 30. When I add those numbers, I get negative 16. So let me go ahead and set this up, and you can finish this on your own. I'll have 5x squared, and I'm going to express negative 17x as a result of negative 15x and negative 2x, and then the 6 just simply gets copied over. And now you introduce your factor by grouping, and I think that you can take it from there looking at the other examples.